Mercury. 2. Cyanide, also known as mercuric cyanide, is a coordination compound of nitrogen, carbon and mercury. It is a colorless, odorless, toxic white powder with a bitter metallic taste. It has a melting point of 320 degrees Celsius, 608 degrees Fahrenheit, at which it decomposes and releases toxic mercury fumes. It is highly soluble in polar solvents such as water, alcohol, and ammonia, slightly soluble in ether, and insoluble in benzene and other hydrophobic solvents. It rapidly decomposes in acid to give off hydrogen cyanide. Samples also decompose when exposed to light, becoming darker in color. It reacts vigorously with oxidizing agents. Fusion with metal chlorates, perchlorates, nitrates, or nitrites can cause a violent explosion. Molecular and crystal structure. At ambient temperature and ambient pressure, Hg(Cn)2 takes the form of tetragonal crystals. These crystals are composed of nearly linear Hg(Cn)2 molecules with a CH-Gc bond angle of 175.0 degrees and an Hg(Cn) bond angle of 177.0 degrees. ALA gives slightly different values of 189 degrees and 175 degrees, respectively. Raman spectra show that the molecules distort at higher pressures, between 16 to 20 kilobars. The structure undergoes a phase transition as the Hg(2) center changes from 2 to 4 coordinate as the Cn groups bind to neighboring Hg centers, forming via Hgn bonds. The coordination geometry thus changes from tetragonal to tetrahedral, forming a cubic crystal structure, analogous to the structure of Cd(Cn)2, due to the ambidentate nature of the Cn ligands. This tetrahedral structure is distorted, but the distortion lessens with increasing pressure until the structure becomes nearly perfectly tetrahedral at greater than 40 kilobars. As in the solid state, aqueous solution, Hg(Cn)2 molecules are linear. Synthesis. Mercuric cyanide can be prepared by mixing yellow mercury oxide with hydrocyanic acid in the following chemical reaction, which is generally carried out by passing HCN gas into HGO in water. When soluble Hg(Cn)2 is formed, the solution is evaporated to crystallize the product, HGO plus 2HCN Hg(Cn)2 plus H2O. Hg(Cn)2 can also be prepared by mixing HGO, finely powdered Prussian blue. In addition, it can be produced by reacting mercuric sulfate with potassium ferrocyanide in water. K4Fe, Cn, 6 plus 3 mercury 2 sulfate 3 Hg, Cn, 2 plus 2 K2SO4 plus iron 2 sulfate. Another method to generate mercuric cyanide is through the disproportionation of mercury I derivatives. In these reactions, metallic mercury precipitates, and Hg(Cn)2 remains in solution. Hg2, NO3, 2 plus 2 KCnHg plus Hg, Cn, 2 plus 2 KNO3. Reactions. Mercury cyanide can be used as a promoter in the Koenigsegg reaction for the synthesis of glycosides. Cyanogen, Cn2, forms upon heating dry mercury cyanide, but the method is inferior to other routes. Hg(Cn)2, Cn2 plus Hg. Coordination polymers can be synthesized from Hg(Cn)2 building blocks. Large single crystals of T-Maida, Cu, Hg(Cn)2, mercury 4 chloride, form upon reacting the labile transition metal halide copper 2 chloride. The soft fluids acid Hg. CN2, and N, and tetramethylethylenediamine, TMEDA. The migration of two labile chloride ligands from harder Cu2 to softer Hg2 drives the formation of the crystal. Past applications. Mercuric cyanide was once used as an antiseptic, but this practice has been discontinued due to its toxicity. One example of this was the treatment of syphilis. A solution of 5 to 10 grains in an ounce of water, painted on with a camel hair brush, was applied to syphilitic sores of the tongue or mouth. Hg. Cn2 is also used in photography. It is still used in homeopathy under the Latin name Hydrogearum bicyanatum. Toxicology. Mercury. 2. Cyanide is one of the most toxic poisons. Its high toxicity is due to mercury in its two cyanide groups. Because of the high solubility of mercury 2. Cyanide in water, it can absorb from skin or inhalation and cause death. Upon absorption it is readily metabolized into both cyanide and mercury, thereby resulting in the symptoms of poisoning by both agents. It is highly dangerous for the environment. National Pollutant Inventory. Cyanide Compounds Fact Sheet. National Pollutant Inventory. Mercury and Compounds Fact Sheet.